Yes, today I'm going to discuss one of the most important chapter for 10th class as well as the for NEET and EAMCENT examination. That is a chapter name is that is optics. Optics here. In this optics here, optics is a branch of physics in which we study the entire properties of entire. We study the entire light. What is the phenomena of light? So all this we can study the about light. That branch is called as a optics branch. Okay, and in this optics we have mainly we have two phenomena. One is a reflection of light, other one is a refraction of light. The first phenomena in the light it is called as a reflection of light, reflection of light, reflection of light, and refraction of light. There are two phenomena. So mainly we have two phenomena. One is a reflection of light, other one is called as a refraction of light. Okay, in this class here, I'm going to discuss the first phenomena that is called as a reflection of light. The reflection of light. Reflection of light. Reflection of light. Okay, so before that reflection of light, so we need to study some terminology which is belongs to the optics. The first terminology in the optics we have two types of optics are there. One is a wave optics. Next one is called as a physical optics. That is, I can write here, write on the board here. The first one is called as a wave optics. Wave optics, and next here physical optics. Physical optics. What is a wave optics means? First of all, I want to discuss physical optics here. What is the physical optics means? So if you take a size of the object, for example, this is my size of the object here. So you know wavelength. Wavelength means, for example, the wave is always so it is always having a positive peak and negative. That is, it is consisting of crest trough, crest trough. This is called as a wavelength. So wavelength means the distance between the one crest and one trough. That is called as wavelength here. So what is the physical optics means here? The wavelength of the light which is small, which is smaller, which is far or less than the size of the object. The wavelength of the light, the wavelength of the letter which is represented by wavelength is lambda. The wavelength of the light which is always less than the size of the object. That type of study is called as the size of the object. So that study is called as the physical optics. So coming to the wave optics here, in this optics here, the wavelength, for example, this is my size of the object here. The wavelength of the light, which is comparably equal to the size of the object. That study is called as a wave optics here. So now we are going to study physical optics. Then after we study wave optics. So the wave physical optics means we can consider light is always having the small wavelength. It is negligibly zero wavelength. That is always which is in the form of ray. The light is always in the form of only ray. That means here we understood that here. So the size of the size of the object which is greater than the wavelength of the light. That is we have to remember in the brain here, because here in entire physical optics, light is always in the ray form. The ray means straight line. Light is traveling in the straight line. Okay. So now I'm going to discuss in this here one more point here. Light. What is the light here? Light is a form of energy. It is a form of energy. It is a form of energy. So by which we can, whenever it fall on the eye, we have some sensation. That means that is called as a light energy. Okay. In this light energy, in this we have one first phenomena that is called as the reflection of light. So reflection of light. Reflection of light. What is a reflection? Reflection means here, for example, if you take a one surface, this is a one side should be silver coated. When light is fall on the surface, which is bounced back into the same medium, that type of phenomena is called as a reflection of light. Okay, this is a reflection of light here. So this is one of the important definition for 2 marks, and also for a board examination, reflection of light here. In the 10th intermediate here, 10th class here, were defined reflection of light. Defined reflection of light means when the light fall on the surface, which is bounced back into the same medium, that phenomena is called as the reflection of light. Okay, next phenomena and types of mediums. Types of medium. The types of medium. What are the types of medium? What is medium means here? It is a path through which light can travel. It's a path through which light can travel. That is called as a medium. So we have three types of mediums here. One is a transparent medium. Transparent. Transparent medium. Transparent medium. The second one is called as a translucent medium. Translucent medium. Translucent medium. And third one is here opaque medium. Opaque medium. There are three types of mediums here. I want to explain first here transparent medium. Transparent means here it is a medium through which a light can which can allow the light completely. Which can allow the light completely. That is called a transparent medium. Transparent medium. The best example is that here. Here is the best example. So here is the best example. We cannot see air here, but that light can travel completely, 100% here. So one more example here, thin glass. So you know that here in the some showrooms like TVS showroom and the MR showroom is here. Sometimes we are unable to find out the glass. That type of glass is called thin glass. That glass is acting as a transparent medium. Next here, translucent medium here, which allows the light 50%. That means partially. It can allow the light partially, 50% of light. That is called as a translucent medium. Best example is here oil paper. Oil paper is the best example, and a trace paper. These are the best examples for the translucent medium. Trace paper. Next here. Last one, opaque medium. Opaque medium means here, this is a medium, so through which light cannot travel. So which cannot allow the light. That is called as a opaque medium. The best example is here. The best example is here wood. Wood is the best example, and wall, and human being. Human being. Okay, these are the three types of mediums we need to understand here. Transparent. So if you want to get a reflection, definitely which medium is required? Opaque medium, because here so that medium doesn't allow the light through that medium. That is called as a opaque medium. Definitely, if you want to get a reflection of light, definitely we need a opaque objects. So for what medium we get reflection of light? Definitely opaque medium. So in the examination, a polyset and MSET exam also is one of the best important bit here. Which of the medium is required to get reflection of light? First option opaque medium, second option translucent, third one transparent, and none of these. So the answer is here opaque medium. So for reflection of light, definitely we require opaque medium. Otherwise, there is no reflection of light. Okay. So this is about the types of mediums. Next here, luminous body. So we need to make a notes. It's very important here. Next here, luminous body. What is luminous body? Luminous body means here it is the object or body which gives the light by itself. That is called as a luminous body. The best example is here. Sun is the best example. Okay, natural luminous body. Next here, tube light. This is a artificial tube light, lamp, and a burning candle. These are called as a luminous body. Okay. Next here, non-luminous body. Non-luminous body. Non-luminous body. Non-luminous body. That means here, so it doesn't give the light by itself, but here one important property is there, which is able to reflect the light. For example, this is my one body is there. That is any body. For example, it is having mass. What, Anna? Yeah, which is having mass here. For example, light fall on this object here. What is the property of this non-luminous body? Whatever the light which is coming from the luminous body, that should be reflected by this non-luminous body. That is which is reflected. That is called as a non-luminous body. So in the examination, this is also very important point here for polyset exam also. This is one of the previous question here. And what is the main property of What is the main property of non-luminous body? First, A option. So which is able to reflect the light? B option. Which is not able to reflect the light? C. None of this. Okay. So the best answer is here. It is a correct answer is here, which is able to reflect the light. It's very very important here. And also fourth option is here. It doesn't give any light here. So my option is B and C. B and C. B and D. Sorry. B and D. So this is about the luminous body, non-luminous body. Okay. Next here. One more thing here. Homogeneous. These are very very important terminology we need to understand. So homogeneous medium. What is a homogeneous medium? So medium. So homogeneous means, for example, if we take one medium, this is a medium, and that I can take this in a space. This entire space is called medium here. If you want to study property of at this point, property of light at this point, at this point, at this point, at this point, the property of the light at every point in this medium is same. That is called as a homogeneous medium. Next here, heterogeneous medium. Heterogeneous. Heterogeneous medium. Heterogeneous. Heterogeneous medium. What is heterogeneous is quite opposite here. So if you take one medium here, okay, if you want to study, for example, if I study the property of at this point, both are different here. That type of medium is called as a heterogeneous medium. So in homogeneous medium, light can travel in straight line. Light can travel in a straight line. Okay. Yeah. This asking one more question also. Which medium light can travel in a straight line? Which of the following medium in which light can travel in a straight line? That is the homogeneous medium. This is also very important for the. Okay, next year. After the ray of light. So ray of light. What is the ray of light? It is a path through which light can travel. Ray means here it's a path through which light can travel. That is called as a ray of light. So this is my ray of light. So this arrow indicates direction here, and this is a ray indicates the path through which light can travel. That is called as a ray of light. Next, in this ray of light, one more point we should know, that is a beam of light. So beam of light. What is a beam of light? Beam means a group. Group. So if you combine all rays, that is called as a group. For example, in this beam of light, we have one more point is a parallel beam of light. Parallel beam of light. Parallel beam of light. Parallel beam of light. And second one is here convergent beam of light. Convergent beam of light. Convergent beam of light. And third one, divergent beam of light. Divergent beam of light. Divergent beam of light. Okay. Yes. Beam. Beam means group. Parallel. All rays should be parallel. For example, I can take this is my first ray and second ray, which are the distance between the ray to ray is very very small here. It's a group of which are parallel. That name is called as a parallel beam of light. Parallel beam of light. For example, next here convergent. Convergent means here the all rays which are meeting on point. That means here the ending point of the ending point of the all rays. Ending point of the all rays should be same. For example, this is my one ray and second ray and third ray and fourth ray. And this is all are meeting at one point. They are convergent. They are convergent. That point, that beam of rays are called as a convergent beam of light. Convergent beam of light. What about divergent? Divergent means they are separated. So they are separated here like that. They are separating. They are separating like this. They are a divergent beam of rays. Divergent beam of rays. Next, last point here. Source. Point source. So right here, point source. What is a point source? Point source means here, its source means which gives the light. What is the point means here? The size of the that source is a very very small. That type of source is called as a point source. The size is very small. So size is a very small. That type of source is called as a point source. Okay. Yeah, these are the terminology we need to understand. So these are all terminals we need to understand. Okay. Yes. Now please take screenshot now. Okay, next one. Go for the reflection of it directly. Next here, reflection of light. So reflection of light for plane surfaces. I want to discuss reflection of light for plane mirrors or plane surfaces. Plane surface or mirrors. So mirror is a plane mirror. You can take plane mirror. Okay. Yeah. Reflection of light for a plane surface. Okay. So in the plane surface, we need to study what are the characteristics of the plane mirror, how to form the image for point image, and for a object which is having some size, and also what are the properties of the plane mirror, what are the application of the plane mirrors, all we have to study. But in the 10th class, it is not it's not there. So in the 10th class, so the topic starts from spherical mirrors, but we need to know this the topic, you should know this type of knowledge here. Okay, next one. So reflection of plane mirrors here, light on the plane mirrors. This is my the plane mirror. Yeah, one side should be silver coated. One side should be silver coated. Other side should be smooth surface, so that we get the reflection. Okay, this is a reflecting surface. One side should be reflecting surface. Other side should be non-reflecting surface, that is a silver coated. It means the light cannot enter through that medium here. So definitely that surface should be opaque surface. Otherwise, we cannot get a reflection. So this is the surface which is a opaque surface. This is a surface which is opaque surface. Then only we can get the reflection of light. Okay, yeah, I can take here one point source. Now image formation by image formation by image formation by plane mirror, plane mirror, plane mirror. Okay, image formation by plane mirror. So first I can take here for point object, for point object, point object. So now we are going to see image formation by plane mirror for point object. So I can take a point object. This is a point object. Point object means here the size of the object is very small. Is a point object here. So you know that here already, you know that here, if you want to locate, if you want to find out the image in the plane mirror, we need to take a minimum 2 incident rays. Minimum 2 incident rays. So before that, here we should know law of reflections. So law of reflections, law of reflection. Reflections. What is law of reflections here? The first law. Angle of I is equal to angle of R. What is the angle of I? Angle of I is the angle of incidence. I indicate the angle of incidence. R indicate the angle of reflection. For example, this is my surface, which is opaque surface. So every time we call opaque surface, because here on the opaque surface only we are getting the reflection of light. Okay. So if you take a one ray which is fall on the surface which is opaque surface, so this is ray is called as the incident ray. This ray is called as the incident. Yeah,
ray.
please mute yourself, just listen the class only. Okay, yeah, this is my incident ray. So always we can give the direction. Whenever we give the direction towards surface, so we understood that yeah, this is the incident ray. So after reflection, so the light is which is bounced back into the same medium. This ray is called as a reflection of light. Reflection ray, reflected ray. So reflected ray. So always we have to show the direction which is away from the surface. That ray is called as a reflected ray. Okay. So now we should draw a normal where the light is incident. Where the light is incident. This is a point where light is incident. That at that point we can draw a normal. Normal means here exactly perpendicular. So what is the angle here? This is angle. This angle is called as a 90 degrees. Normal means here which makes an angle of 90 degrees with respect to the surface or with respect to the plane mirror. That is called as a normal. I can indicate this is N here. So what is the angle of incidence? Angle made by the incident ray and normal, that is called as the angle of incidence. This is the angle of incidence. Angle of incidence. Yeah. What about reflector? The angle of reflection. Angle made by the reflected ray with normal is called as the angle of reflection. Okay, this is very important. So whatever the angle of incidence, that should be is equal to the angle of reflection. Already you know that this all this point here. Already we have already you know that it is a property of the law of reflection here. Angle of I is equal to angle of R. Next here, second one. So incident ray, and reflected ray and normal should be lie in the plane. Should be lie in the plane. There should be coplanar. Coplanar means here. So incident ray, reflected ray, normal should be on the place. For example, this is my board is there. Can you draw the incident ray, reflected ray, normal? Yes, we can draw. So not, for example, three-dimensional. So it is not a plane here. Okay, it is three-dimensional here. So all should be on the plane surface. That's why all should be in the plane or coplanar. That is the property. That are the properties of the law of reflection. So these laws are applicable to the any type of surface. If it is a spherical mirrors, if it is a plane surface, what type of mirror it is. So definitely you can apply these type of reflections here. So in the polyset examination, and one of the question from the polyset here, that question is here. Law of reflections is valid for A option convex mirror, concave mirror, C option plane mirror, D option all. So my answer is all. Very very important here. So all law of reflection not only for plane mirrors. So these laws are applicable to spherical mirrors also. So we need to remember this very very important here. Angle of phi is equal to angle of r, and next property here is I means a incident ray, reflected ray, and a normal and should be lie in the plane or coplanar. Coplanar means they are in same plane. That is called as the first line and the second line. Yes, coming to the image formation with the plane mirror. See here, this is my object here, small object. So point object. Point object means here the size of the object is small. That's why we call the point object. Yeah. If you want to form the image, if you want to form image by plane mirror, definitely we should take a two instant. For example, you know this is my object here. From the object, so many rays are going. For example, this is our one ray. This is the other ray. Because here these rays are coming from the sun here. So all rays are fall on object which is reflected. Because here my object is here non-luminous body. You know, just we have studied that here non-luminous body is a having capability to reflect the light here. That's why. So this is a light fall on object which reflect in all directions, in all directions here. Okay, so many rays which are reflected from the object here. So to form the object in the plane mirror, so we take only two rays. So I can take only two rays here, which incident on the mirror. Definitely that rays must be incident on the plane mirror. So I can take this is my point object. This is a point object. O is my point object. I can take two rays here. This is one ray. This is the incident ray, which is coming from the object. One more ray. I call incident ray also. Second incident ray, which is coming from the object here. Okay, yeah, this is my incident ray one, and this is the incident ray two. Incident ray one, incident ray two. Yeah, you know that here. So where the light is incident here, this is a light which is incident at this point. At this point, we can draw the normal. Normal means a not normal to the this instant ray. That line which is normal to the surface. That means exactly this is my normal. This is my normal. This is normal line. Okay, this angle, you know, angle of incidence. Angle made by the this incident ray and normal is called the angle of phi. Angle of phi. Where is the reflected ray? Must be upper. So this is my reflected ray. This is angle of R. This is my reflected ray. So this is the entire information for the first incident ray. So same thing we have to follow for the second incident ray. So light which is instant on this point. So this is point instant point one, instant point two here. Again draw the a normal line which is normal or perpendicular to the this normal. This is my normal line which is normal to the surface. So this is my normal number two. This is normal number one. Okay, where is the angle of incident? This is my angle of incident because they are angle made by the second incident ray and normal is called as the angle of incidence. Yeah, where is the reflected ray? That should be below the normal. So because this is a normal, this is a reflected ray. This is my ray is called as a reflected ray. Yeah. but these rays are not meeting. For example, if you see from this side here, so they are not reaching. So they are, for example, if you take here a ray here, they are not meeting. They are not. This is the one reflected ray, second reflected ray. They are not meeting one point here, but our eye feels that here. These, if you take the back rays here, this is my back tracing of two rays, two reflected rays. So this is my back tracing here. They are meeting here at this point. This point is called as a image. Okay, so our eye feel that these two rays coming from the this point, so there is a formation of image at this point. Actually, these two rays not coming from this point. Actually, they are coming from object only. Okay, that's why this image is called as a virtual image. This image is called as a, we cannot catch this image. So this is a virtual image. What is the virtual? What is the actual image definition here? What is image? Image means here it is a point of, it is a point where reflected rays are intersected. So this is a point of intersection of, it is a point of intersection, the point of intersection of all reflected rays, all reflected rays, point of intersection or reflected rays. That is the image here. In that image, we have two types of images are there. One is a real image. One is a real image. What is real image here? Real means the reflected rays really meet. The reflected rays. So these reflected rays not meet really. They are appears to meet. That's why that image is called as a virtual image. So if it is really meet, if the reflected rays, if the reflected rays, if the reflected rays are really made, that is called as a real image. What is a virtual image? What is virtual image here? They appears to meet all reflected rays which are appears to meet. That is called as a virtual image. Appears to meet. That point is called as a virtual image. So in the examination, in the board examination, for especially in the 10th examination, for 2 marks question, it is very short answer questions. Define real image, define virtual image. Real image means here it is a the reflected rays in the point of intersection of reflected rays which are really meet. That is called as a real image. Virtual image means here, so it is a point of intersection of extended reflected rays or appears to meet what one point. That point is called as a virtual image. Simply, the point of intersection of extended reflected rays is called as a virtual image. What is the real image? It is a point of intersection of reflected rays is called as a real image. So this is a very important uh, question for the 10th examination, so state board examinations. Please keep in brain here. So image, real image, and virtual image. And image formed by plane mirror for point object. So they're asking here, draw the image formation by plane mirror for point object. So we can draw this diagram here. Okay. Yes, this is about the image formation by plane mirror. So I can take one more here, image formation by plane mirror for a object which is having some size. I can take. Please take a screenshot. Right. Right. Next here, the image formation by plane mirror for a object which is having some size. Which is having some size. Okay. So again, I can take here. This is my plane mirror. This is my plane mirror. One side should be silver coated. So that plane mirror is a opaque surface. Okay. Yes, I can take this is my object which is having some height size. Let it be, this is the bottom point. Upper point is A and bottom point is a B. The height of the object is A. That is a H. The height of the object is here H here. Okay. Now I want to form the image in the plane mirror. Same concept here. So take two rays from the top point. Take two rays from the bottom point. Then automatically we can get the image between the top one and bottom point here. Okay. So I can take here first two rays from the top point. This is the first incident ray. and second incident ray. This is my second incident ray. Okay, yes. So again, draw the normal at this point. Same concept here. This is normal here. Normal n here. This is incident ray. Angle made by the incident ray and with normal is called the angle of incidence. Where is the reflected ray, which is above the normal? So this is my reflected ray. This angle is called the angle of R. Angle. So for every in the 10th examination, we need to mention direction as well as we can write a name also. This is a reflected ray. Reflected ray. Reflected ray. This is the incident ray. This is the incident ray. So that the examiner understand. So you know everything like that here. You never see the entire matter. So only you can see only diagram. Diagram is very very important. The physics here, diagram is very important here. So the student who draw diagram neatly, definitely will never see the writing part here. Okay, right. This here, this is reflected ray. For second incident ray, draw the normal. This is the angle of phi. Where is the reflected ray? Below the normal. This is the reflected angle. So write the incident ray and reflected ray. And back trace. If you back trace it here, so there is a formation of image. So this part we can get here at this point. Okay, yes, same. I can take one more point here. I can take here bottom part here. Again, we can take a 2 rays which are coming from the B point. This is the second one. First incident ray from the B point. Incident ray. Second here. This is the second incident ray. Same. Draw the normal, and this is the angle of phi. This is my reflected ray. This is the angle of R. And again, this is my normal, and this is my reflected ray, R. Again back trace it. Again back trace it here. Again back trace it here. We get this point. So this is my point here. So this is my. If you take at this point 2 rays, definitely we get this point here. If we take 2 rays from this point, again we get this point. If we take 2 rays from this point, again we get your image. If we take like that, we can take every 2 rays from the object here. We are forming the entire image in the. Okay. Yes. Next step. So from this again, if you in the examination, you may ask here image formation by plane mirror and for object. Draw the image formation by plane mirror for object. Draw the ray diagram. This is ray diagram. This is called entire ray diagram here. The plane mirror for the point, not point object here. The object which is having size of height h here. Okay. From this analysis here, we need to make characteristics or properties. So next here, the characteristics of plane mirror. First property here. Tell from this entire analysis here, this is the size of the object. This is size of the image. So both are same. See here, the size of the object is equal to size of the object. First point here. First property is size of object. Size of object is equal to size of image. The first characteristic or first property. Next property here. If the object is real, what is image here? Image is virtual. If the image is real, object is virtual. Vice versa. Okay. If object is real, image is virtual, and vice versa. Vice versa means repeat. If the image is real and the object is virtual, so vice versa. Next step, magnification. What is the magnification? Magnification means here we can compare size of the image with respect to size of the object. Here size of the image to size of the object, both are same. That's why magnification is always one. I can write formula here: size of image by size of object. Size of object. This is a magnification. Size of the image is equal to size of the object. Both are same. Therefore, magnification is equal to less 1. Okay. Next point here. Next point is very very important here. So radius of curvature. Radius of curvature is a big. So it means here it is infinity. Radius of curvature is r is equal to infinity, and focal length. Focal length also infinity. Focal length also. I'll define focal length in the spherical mirrors so that we can understand. Focal length also infinity. It is a small f, that is infinity. Okay, na? In the polycity examination, in the examination also, one of the question here, the focal length of plane mirror. The focal length of plane mirror is A option 1, B option greater than 1, C option less than 1, D option infinity. My answer is infinity. Next, radius of curvature for plane mirror. First option, m is equal to 1. Sorry, not m is equal. Radius of curvature, r is equal to 1, r less than 1, or greater than 1. D option, r equal to infinity. So both are infinity. So we need to choose the correct option. Okay. Right. This is the characteristics of the plane mirror. Okay. Next year. After this year, and also MSET examination also. These are the very important points here. For MSET examination, these properties are characteristics of plane mirror is very important. We need to focus all these points. Okay. Next one. Next, image formation, multiple images or image formation by plane mirrors. Multiple images. Multiple images. Multiple images by plane mirror. Plane mirror. Okay, one of the formula is there. So number of images n is equal to 360 by theta. Remember this here. Very important for the MSET examination. You may ask theta is given number of images. Option C, option A, option B, option C, option like that. They're giving angle here. Theta is given. They find the number of images. Okay, right. So I can write now. So here n is equal to for n. If n is even, if n is even, so number of images formed by the plane mirror is here n minus 1. Next here, if n is odd, the number of images is equal to number of images is equal to only n. Example here, I can take this. So I can take this one plane mirror. This is a M1. This is a second mirror, M2. We can place the two mirrors, which makes an angle of theta. So angle between the first mirror and second mirror is theta. That is inclination theta. Yeah, this is theta. Okay, now I place the object at this point. So symmetrical. Symmetrical means here. So this is a position of the object in such a way that that point divide the entire angle equal. That is called as a symmetrical. Asymmetrical. Asymmetrical means here, for example, theta is equal, for example, I can take 90 degrees. Okay, and I want to divide into two symmetrical angles here. Theta 1 is equal to 45, theta 2 is equal to 45 degrees. That means here, so exactly we can place the object such that that object divide the two mirrors at equal angle. That is called as a symmetrical configuration. Next here, theta 1, for example, same angle, total is 90 here. I can take this is, for example, 30 and theta is 60. Okay, this is asymmetrical configuration. Okay, yes. Next here, in this, for example, I can take n is equal to 60. I can take here. So theta is 60. If theta is equal to 60, theta is equal to 60 degrees. So n is equal to 360 by 60. What is the answer? 6. So n is equal to 6 here. N is equal to 6 means here definitely it is number of images are n minus 1 because n is even. Therefore, number of images is equal to 5. Number of images are 5. Okay. Next, if theta is equal to again, I can take here again 30. I can take here 30 degrees. N is equal to 360 by 30. So this will cancel. 3 ones are 3 2. Again 12. Again even here. So the number of images are 11. Okay. Yeah. If your theta is equal to 72 degrees here. Therefore, n is equal to 360 by 72. What is here? What is the answer here? Answer is here 3. Okay, 3 is odd number here. Therefore, number of images total is only 3 images. If we get fraction, for example, if you take one angle like that here, if you divide that angle with the 360 degrees here, for example, some angle theta is some angle is there. If we get fraction, for example, 4.2 degrees like that here, we take only the fraction. This is the integer part only. For example, if you divide any angle with 360 degrees here, 360 by theta is any angle. If we divide this one here, if we get, for example, fraction again, 3.6. In that case, we can take only integer part. So number of images are only 3. This is the point we have to observe. We should know. Okay, because here in the previous MCET examination, so many questions from this area. N is equal to 360 by 3, number of images. If it is n is even, what is the number of images? If n is odd, what number of images? If it is fraction, what is the number of images? If it is fraction means here, definitely we can take only integer part. Integer part, yes. Next year, please take the screenshot. Right. Deviation for the single mirror. Deviation for plane mirror. Deviation for plane mirror. For example, if you take this in my mirror, plane mirror, next year. So I can take this is my instant ray, which is fall on this mirror. This point is called the point of incidence, and draw the normal. This is my normal here, n. Next, reflected ray. So this is the angle of incidence. Angle of reflection is reflected rays must be bounced back into the same medium. This is my reflected ray. This is the angle of R. Okay. Yeah. Actually, what is the deviation means? This is a reflected ray. Ray. This is a reflected ray. Okay. And this is the angle. The angle between the surface and the incident ray. This is the glancing angle. That is alpha. Alpha is called as the glancing angle. And also the angle between the reflected ray and the surface is also glancing angle. Alpha. Is also I can take this also alpha. I can take beta. Let us suppose this is beta. Beta also glancing angle. Glancing angle means here angle between the incident ray and the surface, that is the glancing angle, or angle between the reflected ray and the surface, that is also called as the glancing angle. What is the angle of incidence here? Angle between the incident ray and normal. What is reflected ray? Angle between the reflected ray and the normal, that is called as the angle of reflection. Okay. My question is that here, what is the deviation angle? So deviation angle means it is angle between the reflected ray and instant ray. For example, if there is no, for example, it is a transparent medium. If it is transparent medium, light is the entire light which is going, no deviation here, no reflection. So light is going in this way. Am I correct or not? Yes, this is my instant ray. Actually, because of this surface, because of opaque surface here, light is reflected in this direction. So what is the deviation here? The angle between the reflected ray and this instant ray, that is called as a deviation angle. This is my deviation angle D. Okay. So actually, how much deviation here? Actually, light is going in this way because of opaque surface here. Light is going bypass. That is should be reflected in this direction. So how much deviation here? The angle between the reflected ray and this instant ray, that is called as the deviation angle. How much a deviation angle? They are asking like that here. Deviation angle means what is total angle here? This total angle is here 180 or not? 180. This total is here 180 or pi. Pi is equal to 180 degrees and pi is radians. Okay. Yeah. For angle of law of reflection, angle of I is equal to angle of R. So I can write I, because angle of I is equal to I. Angle of R is equal to I. So here I can write here total. So 180. This is total is 180. That should be is equal to I angle of I plus angle of phi plus angle of R plus angle of D. Angle of R plus angle of D. Okay. Yes, phi is equal to angle of phi. That is I can write here angle of R, because angle of R also I. In the place of R we can write I here. This is a D, angle of deviation. So I plus I 2I. So phi is equal to I plus I 2I and plus D. I want D here. D is equal to bring plus 2I. If you bring this side here minus 2I. Mathematics, basic mathematics here. If you bring plus 2 inside, it becomes minus 2. So here 5 minus 2i. This is very, very important for single mirror. For single mirror, angle of deviation is here 5 minus 2i. 5 minus 2i. That is 180 minus 2i. Okay. In the examination, MCET examination, for single mirror, single plane mirror, the angle of incidence is 30 degrees. If angle of I is equal to 30 degrees, what is the angle of deviation? So simple is the formula. D is equal to 5 minus 2i. Phi means here 180. Yeah, pi minus 180. 180, pi means 180 degrees. 2 into I means 30. So 180 minus 2 into 30, 60. That is a 120 degrees my deviation angle. So this is a I plus I, 30 plus 30, 60. So 60 and 180 minus 60, that is 120. This deviation angle is here 120 degrees. So this is a question. So you may ask in the MSET examination as a polyset examination. Polyset means after 10th, so we are writing a polyset exam. Okay, right. Next one. Next year. So this is a deviation for the plane mirror, single plane mirror. If it is a two plane mirrors, what is the deviation angle? Please take a screenshot. Right. Deviation for the two plane mirrors. For example, I can take this is a one mirror, second mirror. They are making angle of we are arranging the two mirrors in the inclined direction. This is the angle theta. The angle between the first mirror. This is the mirror one. This is the mirror number one, mirror number two. So yeah, the ray which is this is my ray, incident ray, which is fall on first mirror because of law of reflection, which is reflected. Light is reflected like that. This is normal. This is normal here. So this is my reflected ray. This is my reflected ray. So this is the normal here. Normal for the second mirror here. So this is the angle of I. This is the angle of R. This is the angle of I. This is the angle of R. Okay. So actually, when the light is going in this direction, the first deviation is this is the first deviation angle delta one. Per second mirror, this is my second deviation angle. Total deviation angle is equal to delta 1 plus delta 2. If we solve it here, we get d is equal to 360 minus 2 theta. So we need to remember this formula. Derivation is not important here. So remember this formula, very important for the MSET examination and polyset examination and NEET examination. We are not going to write a board examination here. The board examination is not asking the derivation here. Just you need to know the formula. D is equal to 360 minus 2 theta. For example, if the angle between the two plane mirrors is 30 degrees, what is the angle of deviation? If theta is equal to 30 degrees, theta is equal to 30 degrees, what is the angle of deviation for the two plane mirrors? If they are making angle of theta degrees, okay? So we should know whenever they are asking the two plane mirrors, so we need to make a picture in the brain. So this is a picture we have to make in the brain here. First mirror and second mirror, they making angle theta degrees, that should be equal to 30 degrees. In that case, what is the angle of deviation? What is the angle of deviation? Total deviation angle. First mirror delta 1, second mirror delta 2. Total is here 360 minus 2 theta. That is here. So d is equal to 360 minus 2 theta. 2 into theta means here 30 degrees. That is 360 minus 2 into 30. 60. That is 300 degrees. This is my total angle of deviation. Okay, next year. If theta is equal to, for example, 90 degrees, what is the angle of deviation? So d is equal to 360 minus 2 into 90 degrees, then 360 minus 2 into 90, 180, that is 180 degrees is my angle of deviation. Okay, this is about the deviation for the single mirror, deviation for the two plane mirrors, which are making an angle of theta degrees. Okay, yes, this is about the plane mirrors. So any doubts? Yeah, one more point here. Velocity of the image, velocity of the object here. Okay, I want to also explain. So this here, velocity of the image for plane mirrors, very important here. So definitely one question from this velocity of the image here, in the MSET examination. Velocity of image. Velocity of image. So I take a plane mirror. This is my plane mirror. This is my object here. O is my object. Image is here. This is image I. Okay. So when the object is moving in this direction with velocity VO. So VO bar means here velocity of the object. You know that here, when the velocity, when the object is moving in this direction, what about the velocity of the image? Image also moving towards mirror or not? Yes. So this is which is the object is moving towards x direction, positive x direction. Image moving towards negative x direction. Therefore, here this is the image velocity of the image. So velocity of the image object is equal to, otherwise velocity of the image is equal to minus of velocity of object. Velocity of object. Velocity of the object. Okay. Yeah. So now this is only velocities of the individual velocities of the object and image. So with respect to the mirror, it means relative velocity of the object with respect to mirror, relative velocity of the image with respect to the mirror, we have to find out. You know here. So relative velocity of the object with respect to mirror should be is equal to minus of relative velocity of the image with respect to the image. Okay, I can write here this. I can split. I can write a velocity formula. You know already in the kinematics study. I will explain. Just to get VO minus VM. So VO velocity of object minus velocity of the mirror. Next is equal to minus of velocity of image minus velocity of mirror. Simplify. So velocity of object. O means object. I can write here velocity of object. VO means here velocity of object. Velocity of object. Next here, VM. VM means a velocity of mirror. Sometimes the mirror also moving. Some problems here. They're giving the giving data is that here velocity mirror also moving. Velocity of mirror. Next here, VI means here velocity of image. Velocity of image. Velocity of image. Okay. Next here. So V bar minus VM bar just multiply minus into plus minus vi bar minus to minus plus vm bar. You bring minus vm bar this side plus vm bar. Then you bring okay. So v naught means velocity of object minus equal to velocity of image plus already vm bar is there. That is the velocity of mirror. You bring minus vm bar this side plus vm bar. You know 2m. That means here vi bar. So 2vm plus vm 2vm. So velocity of object. First, I want your velocity of image here. Velocity of image is equal to you bring this side here. Velocity of object minus 2 times of velocity of mirror. This is a vi is equal to v naught minus. This is very important formula. So velocity of image is equal to velocity of object minus 2 times of velocity of mirror. This is very important formula. We need to remember while doing the velocity problem. Velocity of the image, velocity of the object, velocity of the mirror. For example, I'll tell you one of the question from the AMSET here. If the velocity of the object is 2 meter per second, okay. Next, and what is the velocity of the image? You know formula. Velocity of the image is equal to velocity of the object minus 2 times the velocity of mirror. Here, velocity of the mirror is not given here. When it is not given means here we assume that here the mirror is not moving. That's for here. What is the velocity of the mirror? 0. So velocity of the image is equal to this is 0 here. Only velocity of the object is there 2 meter per second. Okay, now this is the velocity of the mirror. Okay, so which is moving in this direction. So velocity of the v naught minus 2vm bar is velocity of the image. That means here which is moving 2 meters in this direction. This is moving in this direction. Okay, this is very important formula we need to remember here. For example, velocity of the mirror also given. For example, velocity of the mirror is equal to 2 meter per second. Velocity of the object also given 2 meter per again this is 2 meter per second. Then what about the velocity of the image? Velocity of the image is equal to v naught minus 2vm. V naught is 2 minus 2 into vm also 2. It is 2 minus 4 minus 2 meters 2 meter per second. That means the direction is different here. Direction is different. Okay, so this is the formula we need to remember. Okay. Right. So this is the today class, Nana. And in the next class, I'm going to discuss spherical mirrors. Spherical mirrors tomorrow. Most of the time, if it is possible, I complete the reflection of light. Spherical mirrors.